how to run OpenStack on Amazon AWS. Probably the first question you would ask me is, why would you actually want to run OpenStack on top of AWS or any public cloud, any different public cloud? But it turns out that it's actually very handy, especially for developing and testing. And I will show you why. Okay, this is our agenda. Actually, I'll start, I'll show you how you usually deploy OpenStack dev and test environments. Then we will talk about how to bring actually OpenStack into a public cloud. And hopefully I will show you a demo of OpenStack running on top of AWS and maybe even on Google Cloud Engine. Okay, I want to emphasize this major point. This talk is specifically geared towards developers who require non-trivial development environments. It also may be useful for enterprise users who wish to try out different OpenStack versions, and also maybe if you want to test new features or configurations, or you already have OpenStack installations in your enterprise, or you want to stage an upgrade without impacting your production environments, it can be quite useful also. We also seen other use cases. For example, it is also very useful for demos, POCs, or training sessions. You can conduct training classes with OpenStack, and it is quite difficult otherwise to deploy multiple OpenStack deployments in your lab. So bringing it to a public cloud can be quite useful. Okay, this slide is actually quite boring. OpenStack, is a cool platform, but it's hard to use. Let's talk about my experience as a developer. As a developer, I have many different environments to play with. I have a source control, for example, when I check in, check out new versions, and I also have multiple branches on my production environment. And usually I have a stable branch where I know that things are just working, and I also have a bleeding edge environment that I can check out, bleeding edge changes, and then I run tests, and I know this environment is not stable. So many times I have a need to have multiple environments. And with OpenStack, it's pretty hard because OpenStack is a beast. It requires quite a lot of compute resources, and it's very hard to have multiple environments installed on a single, on a single machine. Also, as an enterprise users, many times I want to test the different features or a new flavor, and I don't want it to impact my production environment. So I want to install a new version, and it is not that easy because current installation process is not trivial and might require many hours spent in installation scripts and dev tools such as Chef and Puppet. So these slides talk about how you usually deploy your OpenStack dev and test environments. You have actually two options. One is your local PC or laptop. When you have, you can install a hypervisor of your choice, for example, VirtualBox or VMware Player or KVM or any other hypervisor. And on top of it, you can install multiple VMs with OpenStack on it. But unfortunately, this environment is not very flexible. It's not flexible enough. It is not powerful enough, and it is not quite good to run anything useful. So you have another options, and another option is to install OpenStack in your lab. Again, the advantage of this approach is that your lab PCs or lab hardware is very powerful. But again, in order to install anything in your lab, you need to approach your administrator, and you need to request new hardware. You need to specialize dedicated hardware, and it's not easy. It's not easy. It's very time consuming also. So again, the logical choice seems to, just to use a public cloud for that. Why not to use just public cloud for dev and test environments? And public clouds are already a de facto choice for, for dev and test, which is not related to OpenStack. So why not to use public cloud for OpenStack as well? Unfortunately, there are a couple of pitfalls in this approach. First of all, you cannot run a dedicated hypervisor in a public cloud. That means, for example, that you cannot run KVM or Zen on top of EC2 or a Google engine, because when you run inside a virtual machine, you don't have a hardware acceleration support for running a hypervisor. So your only choice is to run containers or to run QEMU, which lacks hardware acceleration, and that means that VMs that would run on top of this environment would be very slow. Your second pitfall is that most cloud providers don't have network configuration required for running OpenStack. For example, you cannot run VXLAN on top of EC2 network because VXLAN require multicast, and multicast is not supported on top of Amazon. So this is why you usually cannot run multi-node setups, OpenStack setups on top of a public cloud. So is it time to give up? In fact, there are many projects that at least try to solve this problem. One of it is DevStack, that most of you probably heard of it and maybe even used it. It is a script that can actually use a public cloud to deploy a single OpenStack VM, and you will get OpenStack installation inside a single VM. Unfortunately, it is very slow because it uses QEMU and also not multi-node. It's almost single node because you cannot actually simulate the networking stuff that OpenStack expects you to find. There are other projects as well, but those projects are not flexible enough and not rich feature-wise. So you are quite limited, and you can't really use the public cloud in its current state for OpenStack. So the question that obvious answer that comes from this conclusion is that you can't run OpenStack on top of public cloud. But I want to actually show you how we can actually bridge this gap and run OpenStack on top of a public cloud. So what we need to bridge this gap? We need three things. One of it is nested virtualization. And nested virtualization means that now we can run a KVM or Zen or ESXi on top of a public cloud inside a VM. This is the first thing. The second element is an overlay network, complex overlay network that will enable you to run any physical layer 2 network on top of a cloud provider. And this overlay network will enable you, for example, running VXLAN or create VLANs or do any other complex stuff that you would expect to do in your physical data center. And the third element is 7 replicating of complex environments. This is actually an enabler or the element that brings agility to your stuff, because when you can save an environment, its state of your environment, and then replicate it in multiple copies, you bring agility to your work process. And I'll show you how can you do this without using complex tools such as Chef and Puppet. You can press a button and save the state of your application, your OpenStack application, your configuration, and later bring it on and run it as is. So those are three elements that are required to bring the OpenStack into a public cloud. These slides talk a little bit about the evolution of virtualization. On the left you can see the x86 hardware, just a regular PC that everyone has. On top of it you run an OS of your choice, for example Linux or Windows, and on top of that you can run applications such as OpenStack. The middle sections talk about the design or architecture of the cloud. So you have x86 hardware, then you have a hypervisor that actually drives this cloud. For example, on Amazon EC2 you have Zen as a hypervisor of choice. And on top of this, the hypervisor actually enables you to divide or to run multiple virtual machines on top of one single x86 hardware. This is actually the state of the cloud today. Now on the right is what we are trying to achieve. As you can see, we developed a special layer called HVX, which enables you to actually run another hypervisor or another virtualization extension on top of an existing hypervisor. That actually means that you can take a VM and run a new and visualize it further. Run multiple VMs on top of it. So actually we get a second layer of virtualization. And if you ask why we need this especially for example, one of the use cases is that we can run OpenStack, KVM powered OpenStack on top of public cloud. You cannot do it without a hypervisor that is developed specifically from the ground up to run inside a virtual machine. Another thing that why we developed this hypervisor is to allow you to take any workload from any virtualization platform and run it on the cloud. For example, you can take a VMware VMDK file and run it on top of Amazon. It will run also. Our hypervisor will enable this. Now, this is quite boring stuff. Again, quite a few technical details. This is how our HVX hypervisor is implemented. We built it actually from the ground up. It's actually built it from scratch. We use binary translation, which is a technique that was used by the original VMware hypervisor. And then before Intel introduced hardware virtualization support into a CPU. Now most of the hypervisors don't use binary translation, but instead use hardware virtualization support, which is a command, which is actually instruction set on a CPU itself that enables virtualization inside the CPU. But again, HVX cannot use this because we run inside the virtual machine. So this instruction set is not available. So we needed a different approach. Okay. Now, an interesting stuff. This is nested visualization. This is actually what enables you to run a KVM on top of ESX or on top of Google Cloud. As you can see, HVX as a hypervisor implemented a VT instruction set that actually allows KVM to run and execute a virtual machine on top of us. Okay. This is not limited to KVM, of course. We can run any hypervisor such as ASXI, of course, on a cloud. Now, overlay network. This was our third element, if you remember. Overlay network enables us to do complex networking stuff, such as supporting VLANs or supporting PXE boot or supporting different any kind of multicast packets and so on. Again, we developed this stuff from the ground up, and it is quite similar actually to what a Neutron implements, but in a different way, in a slightly different way. It runs on the top of a public cloud provider's network, and it actually enables you to do all this interesting networking stuff on top of it. Now, this one is what we were gathered for. It is an OpenStack application demo. This is the design of the design of the demo application I want to show you. I want to show you actually four virtual machines that will run OpenStack application. One of these virtual machines is a controller node. The second one is networking node running Neutron, and we have also two compute nodes running KVM. Now, this is an RDO or Red Hat OpenStack distribution. We chose it not because only RDO can work on top of us, but because it was because of the way it was quite easy to install. So we took it and we installed it in a matter of minutes just by running PEGStack script. And after that, we have a fully functional OpenStack application running on top of Amazon AWS. That doesn't mean that you are limited to 4 VMs or 2 compute nodes. You can run as many compute nodes as you want. We're not limited in this. This is just, again, a sample. Okay, I'm going to show you this right now. Okay, I cannot see it on my screen, so I have to look at this slide presentation. As you can see, this is our environment. We actually implemented a SaaS environment, or a cloud as a service. So this environment right now runs 3 replicas of the same application, of the same OpenStack application. 2 of these replicas run on top of Amazon AWS, and 1 replica runs on top of Google Cloud Engine. Now, those are three identical applications. Those are fully fenced applications that we configured only once. We saved it, and then we just run 3 different replicas. Let's see how it is. Let's see how it can be used. I need to guess where I put my mouse click. Oh, this one of them. And as you can see, it has 4 nodes. And now I'll go to the controller nodes. I'll try to do that. Quite hard to do that. Okay. Okay, I can click the go button. That will take us, or not. This will take us to the the URL of the OpenStack, and this is one of the replicas that runs on top of AWS. As you can see, it is a fully functional application. It is powered by KVM, meaning I can run virtual machines really fast, and this application is everything is fully functional. I'm trying to guess where I put my mouse click. Project, instances. Yesterday I spun the 2 VMs, as you can see. Let's see if it runs, if it still runs, if it's still running. You can see it is okay. Hopefully I can ping Google. Believe me, it works because I tested it yesterday. As you can see, it is a non-trivial setup. You cannot deploy this non-trivial setup by using DevStack or by using any other tools because of the limitations that I already discussed. So again, let me show you our environment. Going back, I run 3 replicas of this environment, so it is really quite useful for them and test. I can make changes, and I can make changes to configuration, and I can edit anything that I want. And later, then after I finished editing and everything works, I can save a copy of this application like this, just by a button click. And then I'll have a template of this application that I can later deploy on a different cloud or in a different region. So I have here a blueprint that I've saved, and you can see I have quite a few blueprints that I saved already. After I save this application state, I can just go and create an application from it and deploy it on a cloud of my choice, just with a button click. Okay, it is. Let's take a different one. And now I can hit publish, and as you see, I can choose a different cloud. I can choose Amazon, I can choose Google, I can choose Microsoft Azure, and all of this is I pay as I go. Okay, let's go back to the presentation. It's not easy. So this is the application that I've shown you. I don't think that I have more time, so let's go to questions if you have any. Thanks. Yes?
Can you talk about the performance? What is the effect to the performance?
Of course, there is some performance penalty, but it is not that hard because our hypervisor is really optimized. For example, for some workloads, we achieve 100% performance of the same native application. It really depends on your workload, but the performance penalty is not that high. It is really useful. In the worst case, I think it can go to 60% maybe performance level of the original application. But still, it's quite useful. Any more questions? Thank you.